those of you who are wondering what I was doing in my free time, well, I was working. I was working on this connection between FactSage and METSIM, and I will just show you briefly what we have so far. So we're aiming at being able to have a version that will be working in the near future. So for now, I'll show you what we have. So you see here, this is the compiler I'm using, and I'm gonna run METSIM. So I'm working in collaboration here with Alex Oldzapel, directly from METSIM International. And like I said, we have a lot of fun at night working on this project. So what you will see today is a modification of the METSIM interface to integrate the FactSage calculation that you saw today directly in this interface. So what I'll show you is directly what has been done so far. So we saw this morning that I want to provide to our FactSage customer with a really simple interface to be able to do basic process simulation, or should I say stream handling. But in the case of METSIM, we're going to another level. So they really can describe way more pyro and hydrometallurgical unit. So there's a clear advantage to link FactSage to METSIM. So here we go, a couple of basic steps, and you will understand what we want to achieve in the near future. So this is the METSIM interface. You have many buttons. Just understanding how to use METSIM is kind of complicated, and it takes some time and probably a workshop to be able to master it. What I want to focus on now is this button right here, model parameter. So now Alex and I, but mostly Alex on this side, he has added a button here in the calc option where we can define heat balance and enable FactSage communication. So by doing that, the software will activate this connection between FactSage and METSIM and will be able to first read CST file. So what you don't see at the moment is the fact that ChemApp is running underneath this environment. In the future, we would like to have this transparent connection between FactSage and METSIM. So what I'll do, I'll again work on my carbo reduction example. So we talked about that today. In fact, here it will not be carbo reduction, but I'll use CO. Okay, so I've already saved a CST file, and if I double click on this CST file, you will see that I'm now building what we call component in the METSIM environment, in the METSIM world, and you see here all the faces that we have activated. So now we can use them, and you'll see that it's quite easy to define mass balance using a FactSage reactor within METSIM now. So I can click on OK, and I can play with the units that are available to us in METSIM. So if I click on here, this HBS pyrometallurgy button, I will be able to select a free energy minimization reactor. I can drag and drop it here or add it to my flow sheet. I will just increase the size of this unit so that you can better see. And now, as we did this morning, we can connect input stream and output stream. So you go here in Gem, and I can add 2 input stream. So that's number 1, that's number 2, and I can also build 1 output stream here. So now one of the interesting features that we already integrated in METSIM is the possibility to impose a mass balance connected to FactSage calculation and to see if this stream is at equilibrium or not. So I'll show you an example. You go here in Edit Object to define the properties of this stream. And now what I'll do, I will add 10 kilogram per hour of hematite again. So I'll go down, I'll go to hematite, and that's a different format. So you see here that we have temperature, pressure in this panel right here, and we can define the weight fraction of hematite here. That would be 1. And there's a neat feature here now. You have this fact button, so you can ask the software if this stream is at equilibrium or not. So under I would say standard condition, hematite should be indeed an equilibrium phase. So if you hit this button, it tells you that the stream is at equilibrium. So that's neat. Now what I'll do, I'll impose the mass balance to the second stream. This one I'll put a gas, so I'll go here in gas, put 10 kilogram per hour, and I will react CO. So this one is interesting because CO at room temperature and a pressure of 1 atmosphere is not a stable phase. So it should form instead CO2 and carbon, and let's see if this is what the software is predicting. So if I hit this fact button, you can see there's a warning now. So CO is not at equilibrium under this condition. It should be a combination of CO2 and graphite. So now for let's say more experiment user, you can change the input and ensure that you're using equilibrium stream. So that's good. And finally, and after that, I will let you dream about the possibilities of this METSIM and FactSage connection. I will just go to my reactor here, and I will define the temperature, 900 degrees Celsius, the pressure, 100.35, and I'll simply enable these FactSage communication, and I can solve this flow sheet. So, okay, it happened already. You can look at what happened here. So you have the results here. So the same output that we saw previously. And if you browse in your, if you have installed METSIM on your computer, you go and see METSIM, and you'll see that a bunch of files have been saved on your computer, and you have the result of the calculation here. So we added 10 kilogram of CO, and we reacted it with 10 kilogram of hematite, and we can see that we have the ChemSage format, and we can explore the result that were obtained. So we have CO, CO2, and we have a monoxide phase with some iron FCC. So that's it. We're still working on that. There's a lot of work to do because the energy and mass balance should be compatible with non-FactSage calculation. So this is where we are, and we're confident that in the near future we'll be able to provide you with an option of connecting FactSage with METSIM. So I don't know. I think I saw some people that were there many years ago and that wish for this connection, and I think we are on the right track to obtain this connection. So that's it for me. We'll complete